the rocket is losing mass, and the fuel that's being expelled is increasing in mass. So it's losing mass in the form of the fuel. So the total mass is not changing, right? So in this isolated system, we conserve momentum. So after the rocket has moved a bit, we have this system where it's lost a little bit of mass, dm, and then the rocket's mass is these should be opposite sides, but we won't worry about that. So we can write the mass before. It's just the momentum at first is mv, and then afterward we've got a little bit of mass heading backward at some velocity, and the mass of the rocket now is going forward. So we could write and say, what's the relative velocity of the fuel with respect to the rocket? And we get something like this. It's just the velocity of the rocket minus the relative speed of the fuel with respect to the rocket.
Right, ready?
So if we plug this in, then we can get an expression for the change in mass versus time. So we get a rocket equation like this.
Okay, so I need you now.
So
I need you now up front.
yeah.
Close on.
So Dale and I are
That's
going to
Dr.
demonstrate how
Bill.
this principle works. So Dale, why don't you tell him sort of how this?
PhD astronomy.
Big as you can.
Yep.
Okay, so this is going to be very loud. Everybody's going to want to shut your ears. And
Look at this little girl.
Is that really loud?
Dude, yeah, that's super loud.
That was loud. I have my ears plugged. It sounded like
Oh
good.
my goodness, that's super loud.
this has a distinctive sound to it. This is what's called a pulse jet rocket. Basically, this was the stuff that the flying bombs that hit from Germany to England in the World War II. This was the engine that was a part of that. And they had that distinctive sound, so everybody knew what was going overhead when they went by. We just used lighter fluid on this for the fuel, and as you saw, once you get this thing started, it just goes until it runs out of fuel. There's no off switch on this, okay? And then the other thing is, this one just has 4 pounds of thrust, and you saw that was enough to actually move this car. This was actually designed for like one of those 8-foot wingspan model jet planes, but the problem is, if you don't get the jet going the minute the rocket starts, the jet kind of burns up because everything gets hot around this thing here. So, that's about what we have there. All right?